outside of our circle. So in finding or solving using the theorem about the congruent circle, so when we say congruent circle, two circles are congruent if they have the same radius. So we can only say that a two circle is congruent if both of the circle have the same radius. And the other theorem or the other base for us to classify that the two circle is congruent if the two arcs are congruent, if they have the same measure and they are arcs of the same circle or congruent circle. So that means we can only classify that a congruent circle is the same or a two circle is equal if both of its radius and its arc are congruent. So that is for the congruent circle, as you can see here in the example that we have in our screen, wherein the angle that measures 145 have the same measurement of a radius with a sign of congruency that you can see here, this line. That means the radius of these two circles are congruent, including the angle of the measurement or the central angle of our circle. It means these two circles are congruent. So let's proceed with the first theorem that we have in the congruent circle. Okay na, can I proceed to the next slide? Okay na, Joff? Hindi pa. So the first theorem that we have in our congruent circle is in the same circle, two minor arcs are congruent, and if and only if their corresponding chord are congruent. So we can only say that the two chords or the two circles are congruent based on its chord. If the two chords that you have in the circle are congruent, as you can see here on the screen, wherein chord AB and chord DC are congruent. That means if we're going to have another circle that has the same measurement with our chord, the measurement of its minor arc is the same with the measurement of the other circle. For example, we have this circle. For example, in the diagram, circle P is equal to circle Q if the chord FG is congruent to the chord JK and the measurement of the arc JK is equal to 80 degrees. Find the measurement of the arc FG. As you can see here in the circle, it composes of two chords. Both of the circle has its two chords, wherein it's stated in the problem that circle P is congruent to our circle Q, where the chord FG has the same measurement of the chord JK. If the measurement of our arc JK, which is this arc, is equal to 80 degrees, what will be the measurement of our arc FG? So according to the first theorem, if both of the chords in the two circles are equal, the minor arc of those two circles are also equal. So that means the measurement of arc JK is equal to the measurement of the arc FG. Since both of the chords in our circle is congruent, as you can see here on the screen. Radius is congruent to the radius of our circle Q. Chord GF is congruent to the chord JK. Since both the radius and the chord in the two circles are the same measurement, so the measurement of the minor arc of our chord is equal to the measurement of the other arc that we have in our circle. So if JK has a measurement of 80 degrees, that means the measurement of our arc FG is also equal to 80 degrees. So that's how we find for the measurement of the arc based on the theorem of the congruent circle, wherein chords and radius are equal. Question in this example. Mahirap, no? Mahirap hanapin yung measurement ng arc on the first theorem. Let's have another example based on this theorem. For example, we have this two circle. We have circle A and circle B. Circle A has a chord which is AB. This is our circle A, and the second circle that we have is circle B. Circle A has a chord which is BC, and circle B has a chord which is VE. Given that the measurement of the arc BC is equal to 3x plus 4, and the measurement of the arc DE is equal to 2x plus 5. So for example, that is the measurement of our circle. Looking at the circles that we have, chord BC is congruent to the chord DE, and the radius that we have in both the circles are also congruent. Given that the theorem that applying that the two chords and the radius of two circles are equal in measurement, its arc has the same measurement or equal also. Since arc BC, the measurement of the arc BC is equal to the measurement of the arc DE. So we're going to find the exact measurement of our arc, given that arc BC is in a measurement of 3x plus 4, and arc DE has a measurement which is 2x plus 5. So to find the exact measurement of our arc, we need to find the value of the variable x. So we have 3x plus 4 equals to 2x plus 5. Combine similar terms in the expression that we have. So we will be having 3x minus 2x equals to 5 minus 4. So the value of x in the expression that we have is equal to positive 1. That's the value for our x. But what we're looking is the exact measurement of our arc, minor arc BC and minor arc DE. So let's solve for the measurement of our arc BC and DE. So in finding the exact measurement, you can either use the equation for the arc BC, or you can use the measurement of the arc DC. You will be arriving the same answer since they are equal. So let's use the measurement of the arc BC, which is equal to 3x plus 4. So 3 times the value of x, which is 1, plus 4. So 3 plus 4, the exact measurement of our arc BC is equal to 7. The same with the exact measurement of our arc DE, which is also equal to 7 degrees. So that's how we find the measurement of our arc based on the congruency of the chord and the radius of our two circles. And now for the first theorem. So let's proceed with the second theorem of our congruent circle. The second theorem that we have for the congruent circle is if one chord is perpendicular bisector of another chord, then the first chord is a diameter. If one diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So, looking at this theorem, if one chord bisect or intersect a diameter or another chord, that means that chord, the other chord that you have, is your diameter. Or we can have another situation in coming for the chord, two chords. If the one who bisects is the diameter and its arc, this two arc that is being divided by the diameter is congruent. The same with this circle, wherein the diameter bisects the chord. The chord that is being divided by another chord, which is the diameter, that chord is also equal in measurement. And we know that perpendicular line or chords or a line that create a perpendicular is always going to have a 90 degrees angle. That's why it's perpendicular. It will always create a 90 degrees once two lines is perpendicular. So we're going to use this theorem to find the measurement of the chord and the angle that we have in our circle. The chord and the arc. For example, we have the circle. For example, in the diagram, circle E, we're going to find the length of the chord AC. Looking at the chord that we have, AF is equal to 7. The diameter that we have in our circle is line BD. That is our diameter. The diameter bisect the chord CA, producing a 90 degrees angle, and we need to find the measurement of this chord CA that we have. If AF is equal to 7, according to the theorem, if the chord is being divided by the diameter, the chord will be having the same measurement or will be divided by 2. So if this chord is being divided by our bisector diameter, which is BD, that means the measurement of AF is equal to the measurement of our line segment CF, since the diameter bisect our chord CA. So the measurement of line segment CF is equal to the measurement of the line segment FA. Given that the measurement of our line segment FA has a measurement which is equal to 7, so our line segment CF is also equal to 7. But what we're looking for is the measurement of the entire chord AC. Kung si AC is being divided by a two-line segment, which is line segment CF and line segment FA. That is the two line segment that is being produced by our perpendicular line or our diameter BD in our circle. So the measurement of our chord AC is equal to the sum of the measurement of our two-line segment that is being made by our diameter BD. So CF is equal to 7 plus the measurement of the line segment FA, which is also equal to 7. So the chord AC that we have in our circle is equal to 14. So that's the measurement of our chord AC. Let's have another example applying the theorem about the perpendicular bisector in our circle. So for example, we have this circle. A diameter or a circle A has a diameter which is BD and a chord which is CE. The chord is being bisect by our diameter BD to form an angle which is 90 degrees. And the measurement of the arc CD is equal to 9x, and the arc DE is equal to 80 minus x. So according to the theorem of a perpendicular bisector, once a chord being bisect by a diameter, the measurement of the arc is congruent. So that means the measurement of the arc CD is equal to the measurement of our arc DE. Since the line that bisect the chord is a diameter. So if the measurement of arc CD is equal to the measurement of the arc DE, for us to find the measurement of our arc CD, we need to find the value of x, which is arc CD is equal to the measurement of our arc DE. Measurement of our arc CD is equal to 9x. Measurement of our arc DE is equal to 80 minus x. So combine similar terms in the expression that we have. So we will be having 9x plus x equals to 80. So 9x plus x is equal to 10x equals to 80. Divide both sides by 10. So the value of x is equal to 8. So we have already the value for our x. To find the exact measurement of our arc CD and arc DE. So to find the measurement of our arc CD, so measurement of the arc CD, which is equal to 9x. So 9 times the value of x that we have, which is 8. So 9 times 8 is equal to 72 degrees. So that is the measurement of our arc CD. So given that we are applying the second theorem of the congruent circle, where the diameter is the bisector of our chord, where the measurement of the arc is congruent. So kung ang measurement ni CD is 72 degrees, that means the measurement of the arc, the DE, is equal to 72 degrees also. But what if the measurement of the arc CE, the entire arc of the chord that we have? So given that we have already the measurement of the two arc that is being divided by our perpendicular bisector or our of the arc CE, we're just going to add the measurement of the arc CD and the measurement of the arc DE. So measurement of arc CE is equal to the sum of the measurement of arc CD and the measurement of the arc DE. So if the measurement of the arc CD is equal to 72 degrees plus the measurement of the arc DE, which is also 72 degrees, the measurement of the entire arc, minor arc that we have in our circle, is equal to 144 degrees. So that is the measurement of the arc CE that we have. So that is the second theorem about the diameter as the perpendicular bisector of our chord. So you can only apply this theorem kung si diameter ang nagahati sa chord. But if it's not, kung hindi si diameter ang nagahati sa chord, it will not be equal. The measurement of the line segment of the chord is equal if the bisector is the diameter. The same with the measurement of its arc. The measurement of the arc will only be equal if the bisector is the diameter of the circle. Okay, now for this example, okay, let's have another example for our second theorem before we proceed with the third theorem that we have in the congruent circle. So for example, we have this circle. Example, we have circle B. With a diameter of DE and a chord which is MN. Given that in our circle B, chord is being bisected by our diameter DE, that produce a measurement of the arc MO or MD, which is equal to 5x plus 8, and the measurement of our chord DN, which is equal to 3x plus, for example, we have the measurement of the chord DM, which is equal to 5x plus 8, and the chord DN, which has a measurement which is equal to 3x plus 10. So we need to find the measurement of the arc DM, the measurement of the arc DN, and the measurement of our arc MN. For example, that is what we're going to solve in our circle B. So given the measurement of our two chord, which is equal to 5x plus 8 and 3x plus 10. So according to the theorem, if the line bisector is the diameter, the measurement of our chord is equal or congruent. So chord DM is equal to the measurement of our chord DN. So the measurement of our chord DN is equal to 5x plus 8 equals to the measurement of our chord DN, which is 3x plus 10. So combine similar terms in the expression that we have. So 5x minus 2x is equal to 10 minus 8. So 5x minus 3x is equal to 2x. And 10 minus 8 is equal to 2. Divide both sides by 2. So the value of x is equal to 1. So since we have the value for our x, we can now solve for the measurement of our arc DM and arc DN. So measurement of our arc DM is equal to 5x plus 8. So 5 times the value of x, which is 1, plus 8. So 5 times 1 is 5, plus 8, which is equal to 13 degrees. So that is the measurement of our arc DM. So since two arcs are congruent, that means the measurement of our arc DN will be also equal to 13 degrees. So we have already solved for the measurement of the arc DM and the measurement of our arc DN in the circle B that we have. Next, we need to solve for the measurement of the entire minor arc MN that we have. Measurement of the entire minor arc MN is equal to the sum of the two minor arcs that we have in our circle. So measurement of the arc MN is equal to the sum of the measurement dm plus the measurement of the arc dn. So dm has a measurement of 13 and dn also has a measurement of 13. So we have 26 degrees as the measurement of our entire minor arc MN. So that's how we use the second theorem of our congruent circle. Okay na, for the second theorem. So let's proceed with the third theorem that we have for the congruent circle. The third theorem that we have for our congruent circle is in the same circle, two chords are congruent if and only if they are equidistant from the center. So as you can see here in the circle, circle C has a two chord, which is chord QR and chord ST. They will only be equal if they are equidistant from the center of the circle. So as you can see here, they have a distance which is UC, the line UC, who has a measurement which is equal to 2x, and a line segment which is CB that has a measurement which is 5x minus 9. The question here, in the diagram of circle C, QR or chord QR is equal to the chord ST that has a measurement which is equal to 16. Find the measurement of the line segment CU or UC. So that means this line, we need to find the exact measurement or the exact distance of the two chords from the center of our circle. So to be able to find the measurement of that line segment in our circle, we're going to use the theorem that we have, which is UC or CU is equal to the measurement of the line segment CV. Since according to the circle, two chords are equal. So kung equal ang two chords that we have in the circle, that means they are equidistant from the center that we have. So measurement of line segment CU has a measurement of 2x, and line segment CB has a measurement which is equal to 5x minus 9. So 2x minus 5x is equal to negative 9. So negative 3x equals to negative 9. Divide both sides by negative 3. So the value of x is equal to positive 3. That is the value for the variable x that we have in our measurement. So substitute the given value of x to the measurement of our line segment CU. So measurement of CU is equal to 2x. So 2 times 3, which is equal to 6. So that is the measurement of the line segment CU that we have in the circle. Okay na, with this slide, Let's have another example for the third theorem that we have in the congruent circle. So for example, we have this circle. Circle C has a chord, which is QR, and chord ST that has a measurement. If chord ST has a measurement which is equal to 32, and line segment UC is equal to 12, and line segment CV is also equal to 12. So we need to identify what is the measurement of our chord QR. So given that the two chord that we have in our circle is equidistant to the center of our circle, that means that measurement of our chord is the same or congruent. So kung si chord ST is equal to 32, that means chord QR is also equal to 32. Since equidistant ang dalawang chord from the center. They have the same distance from the center, which is 12. So the measurement of the two chord is the same. So we need to find the measurement of our line segment UR in our circle. So line segment UR. This. So if line segment QU is equal to 16, so kapag hinati natin yung chord into half, you will be having the same measurement. So that means the measurement of the line segment UR is equal to 16 also. Since the whole measurement of our chord QR is equal to 32, and half the chord, which is equal to 16. So we are done finding the measurement of our chord QR, which is equal to 32, and the line segment UR, which is equal to 16. The next question that we have about the circle that we have on the circle is, what is the radius of our circle C? Given that we have an equidistance, which is 12, we need to find the radius. The radius is this line. Radius QC of our circle. So, since we're going to find the measurement of this radius, we can apply using the Pythagorean theorem to find the measurement of our radius, since we have a right triangle in our circle. So using Pythagorean theorem, which is hypotenuse is equal to the sum of two sides of the right triangle. So we have A, which is equal to 12 squared, plus the other side of the triangle that has a measurement, which is 16 squared. So 12 squared is equal to 144. Plus 16 squared, which is equal to 256. So 144 plus 256, which is equal to 400, square root of 400, which is equal to 20. So the radius of our circle is equal to 20 units. So that's how we use the theorem, the third theorem that we have for our congruent circle, wherein two chords are equal if they are equidistant from the center of our circle. For example, we have this circle. For example, we have circle A and a chord, which is BC, and chord DE. If our two chord is equidistant to our circle that has a measurement or a distance which is equal to 3, so we need to find the measurement of our two chord. If the measurement of the chord DE is equal to 6x plus 5, and the measurement of the chord BC is equal to 2x minus 1. So we need to find the exact measurement of the two chord that we have, which is chord BC and chord DE. If these two chords are equidistant from the circle, from the center of our circle that has a distance which is equal to 3 units, what is the exact measurement of our chord BC? So to find the measurement of the exact of our two chord, since it's equidistant, that means the measurement of chord BC is equal to the measurement of our chord DE. So kung si BC is equal to 2x minus 1, the same measurement with our chord DE, which has a measurement of 6x plus 5. So combine similar terms. So we have 2x minus 6x equals to 5 plus 1. So 2x minus 6x is equal to negative 4x equals to 6. Divide both sides by negative 4. So the value of x is equal to 6 divided by 4, negative 1.5. So if our x is negative 1.5, what is the exact measurement of our two chord? Give me the exact measurement of the chord BC and chord DE. If our x is equal to negative 1.5.
Negative.
Yes, Bernadette, what's the exact measurement?
Negative 4.
Negative 4. According to Bernadette, it's negative 4. Chord BC is equal to negative 4. The same with our chord DE, which is also equal to negative 4. Tama ba? 2 times negative 1.5 is positive negative 3. 3, tama, negative 4. Negative 3 minus 1 is equal to negative 4. Okay, now with our third theorem for the congruent circle. But what if we're going to solve for the radius of our circle? Given that we have already the exact measurement of our chord BC and chord DE, what will be the radius of our circle? Solve for the radius of the circle A that we have. What is the measurement of our radius? Na, sino nang may measurement for our radius of circle A? Okay, let's solve for our radius. So radius AB is equal to the sum of the line segment AM squared plus line segment MB squared. So the measurement of AM is equal to 3 squared plus the line segment MB MB is half of the chord BC. So kung half siya ng chord BC that has a measurement of -4, then it means measurement of this line segment MB is equal to -2. So 3 squared is equal to 9 plus -2 squared, which is equal to 4. So 9 plus 4 is equal to 13. Square root of 13, which is equal to 3.6. So the chord AB has a measurement, or the radius AB has a measurement which is equal to 3.6. So that's the measurement of our radius in the circle A that we have. Question. In the three theorem of the congruent circle, okay na? Okay na, drop. Can I clear the screen? So tomorrow we're going to proceed with our discussion with the shape inside of the circle and the shape outside of the circle. So that is what we're going to discuss tomorrow. So goodbye everyone and see you tomorrow.
Bye.
Bye.